All right, we're going to go ahead and get started here. Good afternoon, everybody, and thank you for being here. Welcome to our September installment of ENERCALC Office Hours. If you've been with us for past sessions, you already kind of know the drill a little bit. If you're joining us for the first time, we just have a couple of quick housekeeping items before we begin today's program. So before we get going, I want to start with a quick sound check. If you direct your attention to the lower right-hand corner of the sessions window, you'll see a chat dialog. If you're able to hear me all right now, just go ahead and throw a thumbs up emoji in the chat so that we can know everybody can hear just fine. Go ahead and throw those out there if you can hear me right now. Perfect. Okay. Thank you guys for verifying that. And before we get on with the rest of our introductions, I also want to go ahead and do a sound check for our primary speaker. So once again, if you can hear Mac's voice here in a moment, go ahead and throw a thumbs up or an okay in the chat as well.
Hello, everyone, and welcome to Office Hours.
Perfect. Okay, now that we have our tech checks out of the way, we are going to go ahead and disable the chat, and we'll move on to some introductions to get going on today's program. Even though the chat is going to be disabled, we do have the Q&A tray in your lower right-hand corner where we can continue to do interactive discussion when we get down to our question and answer part of the program today. So let's go ahead and do some introductions. My name is Seth Roseworm. I'm Senior Structural Engineer and Software Developer here at ENERCALC. And our presenter for our monthly ENERCALC Office Hours program is Mac Elterhoney. Mac is a senior structural engineer here at ENERCALC, and he kind of splits his time between providing technical training for ENERCALC customers, working with the ENERCALC engineering team on specifications and technical behavior of our software, and also helping maintain a presence for ENERCALC at national events. So Mac is also the founder and managing principal of ELTA Design Group, which is a specialty structural engineering firm based in Oklahoma City. And he's been an ENERCALC user for about a decade, so he has a lot of great insight about the needs of our customers. So for anybody who's new to Office Hours this month, the Office Hours program is meant to provide simple and direct lines of communication between us and our customers. And we block out time for several different things as part of that. Mainly, we showcase new features and updates to ENERCALC software. We also show optimized design workflows. A lot of times we block out time to answer previously submitted questions, written questions that engineers have sent in to officehours@enercalc.com. We also do live Q&A, and we'll have plenty of time for Q&A today. And if there's any question that's too involved or requires deeper digging or research, then that would be a better fit for our support team, support@enercalc.com, to reach the support team, and they can investigate your concerns and look deeper on those things. So as a minor point of order, you'll notice everyone's microphones are muted just to make sure we don't get any echo or feedback during the session while Mac's presenting. As I mentioned, we do have open Q&A at the end of each and every Office Hours session. So to submit a question for today's Q&A, just use the Q&A dialog in the lower right-hand corner of your sessions window. If you experience any audio problems at any point during today's session, you can simply refresh your browser or simply get out and rejoin the session, and that should be able to take care of you. If you ever want to rewatch today's program or share it with someone, the recordings to each of our Office Hours sessions get uploaded to our Office Hours playlist on ENERCALC's YouTube channel. And with that, I will go ahead and hand it over to Mac to get us going on our program for today.
Thank you, Seth, for the introduction. And hello, everyone, and welcome to another session of our monthly Office Hours program. I would like to start our session with a brief overview of the overall agenda for today. We will be covering ENERCALC latest build, register for Office Hours to get notified, what's new in ENERCALC, with column and stud design, and lastly, we will have a live Q&A. So we have a full program. We have a couple of housekeeping items that I like to get out of the way early on. And the first thing is, are you on the latest build of ENERCALC? So if you open ENERCALC and you look at the top, you will find your current build of ENERCALC. We want to make sure that you get notified of any new updates. So you're always taking advantage of the newest features and that we implement in ENERCALC, and we actually have updates monthly. So the way to go about this is you click on the update button and you check the box at the bottom that says automatically check for updates at program startup. The latest build of ENERCALC right now is for the month of September, And before we dig into that, I want to, for the users, I want to let you know, for the users who are on build 2023 830, so that's the August 30th of 2023, all the way to 2024 February 28th. So for those users on those builds, the feature to notify you of the availability of new updates does not function properly. So if you're affected, then the user will need to do one manual update, and it's just a one-time thing. And the way to do it is you can do it either from ENERCALC or through our website. If you are on build 2024 March 4th, so that's the March 4th update. If you're on that one, if you're on that build or newer, then you do not have this issue, and it's safe for you to ignore the slide. If you are affected, or for some reason, if you want to do a manual update, it's very simple. You just click on the update button at the top of your ENERCALC, and then you click on the second button right here that says click to launch for our users page. When you click on this, it'll just bring you to our website, and you can click on the updater. And once you click on that, it'll download a .exe file for you, and you can just run it. Once you run it, your software will update to the latest and greatest. And don't forget to go back and make sure you check the automatically check for updates at program startup. Have that enabled, so this way you're always reminded of new updates, which again do happen monthly. The current build of ENERCALC is the 2024 93 or 0903, which is the September 3rd. This was released last week. Next, I would like to encourage everyone to register for the office hour program, so you can get email notifications directly to your email. Typically, the email address we have on file is for the IT department, or maybe an admin that manages the office licenses. And sometimes these notifications about educational sessions never actually make it to the engineer and just stay with the IT person or the admin. That's why I encourage everyone who's interested in these monthly sessions to register on our website to be notified. And you can always unsubscribe as needed, and this is open to active subscribers as well as non-subscribers. And with that being said, you can register by going to enercalc.com/office hours. That's one way of reaching the page. And if you don't want that, you can just simply go to our website, enercalc.com, and you can navigate to it by clicking on the For Our Users drop-down menu, and then click on Office Hours Live Monthly Education and Q&A. Once you click on this, it'll take you to our registration page, which is a very simple page. Pretty much you input your email address, you put your name, and if you're an active subscriber, we ask you to enter your registration number. If you're not a current user of ENERCALC, then you can leave that blank. Then you can click on the submit button, and this way you will be included in the email list. And then lastly, at the bottom, we regularly update the info regarding the next office hour session. So this way you will be able to find more information about a calendar invite, and you can see right here, this is the events page. So you can just click on this link right here, and that will get you to the sessions page. Moving on to the next part is that the recordings, as Seth was just saying, that we have these unedited recordings of these sessions uploaded to that same webpage, which is enercalc.com/office hours. You can go there, and if you scroll down a little bit, you will find all of these previous recordings, and this is the place for today's recording. So the latest one that we did was August, and that's already uploaded. And the one that will finish today, in the next few days, it will be uploaded and available for viewing. Moving on to the what's new in ENERCALC. Last week, the ENERCALC team was at the conference that was held by the Structural Engineers Association of California and the Northwestern states. And many of the engineers we talked to were not fully aware of all of the new features that we have recently introduced in ENERCALC. So I decided to include a quick recap of some of the latest features that we introduced, and kind of walk you through it in a quick fashion. The first feature is the decoupling of the IBC and the ASCE editions. So some jurisdictions recently started mixing and matching codes and design standards. For example, they might want to use the IBC 2015, but they also want to use the ASCE 716. Traditionally, the ASCE is lumped up under the IBC that it references. So for example, here in ENERCALC, you will have the, for example, IBC 2015, and it automatically grabs the host of design standards that are referenced by the IBC 2015. That means ASCE 710, NDS 2015, ACI 31814, and so forth. So that's how it used to be all lumped up. However, now after decoupling the IBC and the ASCE editions within ENERCALC, now you can actually mix and match and use whatever combination you'd like. So you can use IBC 2018 with maybe ASCE 722. This gives you a little bit additional flexibility in following your local jurisdiction if you are in a jurisdiction that requires the mismatching or the mix and match of codes and design standards. The second update is the ASCE 722 seismic base shear. So for the longest time, all of the loads and forces are housed under the loads and forces folder, as you can see here on the left-hand side. Now, these are specific modules, and each ENERCALC project will only get one of these. The idea is that you're working on one building, so your wind load, your snow load calculations are not changing. You do one for them and for that one building, and that's it. So hence, you only needed one of each. However, with this new update, we decided to change that. So if you have the latest build of ENERCALC, you will be able to see a new tab. Once you click on the Add button, you'll see a new tab that says Seismic Loads. And under it, there is a new module called ASCE 722 Seismic Base Shear. Now you can add as many of these as you want, and the plan is to move all of the loads and forces modules, such as wind and snow, to kind of make them similar to this ASCE 722 Seismic Base Shear. We'll just have a bunch of them, and you can, again, use them as needed and create as many copies or as many of them as you would like. Another thing, which is native load linking within ENERCALC, we did actually an office hour session about this a couple of months ago when it was first released, but I was surprised to see that so many people didn't know about this. So I just kind of wanted to have a quick recap to tell you a little bit more about it. So this is one of our most requested features, which is the ability to automatically link reactions from one calculation to another, and the ability to change something in one member and push one button to have the effects of that change trickle down to all of the supporting members. So for example, if you have a beam and a girder, all of the, you change something on the beam, it'll automatically change or update that reaction in the girder. So ENERCALC has done just that. And you can see here that we have a brand new tab called the Calc Order. And this tab organizes all of your calculations based on the load path order. So you have here a list of all the calculations that are actually linked. If you have calculations that weren't linked, they will be right here separately. But the linked calculations are in the load path order. So that means you can actually see here beam 1 and then primary girder, then transfer girder 1 and transfer girder 2. So this is named in a way that makes sense. So this way you can follow it. But even if this is made in a way that doesn't make sense at all, it would still, of course, follow the load path because it understands the load path. And you can link multiple reactions from multiple members at the same time. And ENERCALC understands the load path logic and ensures that all the calculations are performed in the proper order. We also added load linking status badges to help you navigate the status of each calculations for each calculation and understand the warnings a little bit better. And that's why you see these badges right here, and that's what each badge means. Also, we have this new button at the top that's named Recalculate Linked Loads. This button allows you to bulk recalculate all of the calculations to ensure that the most up-to-date reactions are being used and their effects are trickling down to all of the related members in the downstream sequence. So that means if I change something in beam 1, all of these beams, because they rely on, beam one relies on the girder runs on transfer girder, and so forth. If I change one thing here, all of these will be out of date. All I need to do is just click on this button, and it'll automatically bring all of these calculations up to date with the most updated and latest and greatest reactions. Inside the module, we added a new tab called linked loads. And within this tab, you have a list right here on the left of all of the calculations that you have in this ENERCALC file, and you can grab reactions from whatever calculation that is listed in this table or in this list. And as you cycle through them, you will be able to see a 2D diagram on the right-hand side to help refresh your memory regarding what, for example, beam one is. That's what it is. It's a W10 by 12. It's a 12-foot span. It has this much load. And down here, it labels the supports. For example, this is support 1. This is support 2. And it shows you the proper reactions that's grabbing from that calculation. Next, you determine how you want the reactions to be applied in your current member. For example, I want it to be applied maybe at the third points. If that's what you need to do, then you just click on link loads. And what happens is that any reaction that's been linked onto this beam will be listed in this table. It's called the linked reactions table. And you can see, for example, we linked this reaction at the 1/3 points, and you can see the right here at the 1/3 point. So overall, load linking is a powerful and intuitive tool that allows the engineers to create a smart and a well-connected chain of calculations while minimizing the risk of transcription errors, as well as, of course, increases the workflow efficiencies. And then the last part about this is our YouTube channel. So if you go actually on ENERCALC's YouTube page and click on playlists, you will find a new playlist that's dedicated to load linking. And in this playlist is a simple and easy to follow list with a step-by-step how-to videos to show you how to use load linking. And it gives you a good idea of understanding the various workflows that you can use. It also explains the status badges in great details to give the user a full, robust understanding of the capabilities. For example, you can see here the first video is a full overview. The second video is a walkthrough of a short example with a voiceover. So there's actually, it's me walking you through the steps and providing some commentary. And then video 3, 4, and 5 are a little bit of a deeper dive into all of the various functionalities. So you can give this playlist to a new engineer or somebody who's never seen load linking, for example, and they will be able to fully understand and follow the instructions and the best practices of how to use this powerful tool. The last thing here that I want to bring up in terms of what's new in ENERCALC is the ENERCALC for Revit, or EFR. We now have a new full gravity load path. And to give you an idea for those who don't know ENERCALC for Revit, or EFR, EFR is a plugin that allows you to design structural members fully within Revit without relying on exporting or importing any of those analytical stick models. That's not what it's trying to do. It relies on the physically modeled geometry of your model to perform these calculations. And of course, it uses the ENERCALC computational engine. So previously, we used to support steel beams, steel composite beams, wood beams, and girders. And the new addition that we just did last week, that was released last week, is the addition of the ability to design steel columns and spread footings. So the way that this work is very simple. You can pick on a column that you have, and that's the new plugin. You can just click on the steel column design, and this kind of walks you through a few commands, such as slenderness in the X direction, slenderness in the Y direction. It understands intuitively a lot of the bracing conditions. And the other thing that it does is that it looks into the tributary beams. So for example, it knows that this column is a corner column and it has 2 beams. So you confirm that. and then it automatically populates a calculation for you. You can give it a name, but it already understands that it's a pin condition. It understands the column size that you already have in Revit. It already brought in the reactions from the beams and the girders that frame into the column. Those are linked reactions. You don't have to touch them. Don't do anything with them. And once you go through this, you can change the size. You can do everything you want in here. Once you do that, it talks back to Revit, and it highlights it in green and says this beam or this column is good to go. The same idea applies for the footings. You can click on the foundation to design, and it'll automatically read the geometry, open a new calculation for you in ENERCALC, and it already grabs the reactions that are coming from the column. For example, you can change the size from a 4x4 to a 6x6, and maybe change the reinforcement to 8 number 6 rebar each way. You click on save and close, and what will happen, you can see it automatically remodels that foundation for you, and it brings it into Revit. It does the same thing with tagging, for example. It tells you exactly what rebar you have. So to be able to access all of this, you just need to download the latest and greatest ENERCALC, and then download to the latest and greatest, of course, ENERCALC for Revit. All of this was released last week on September 3rd, and you'll have all of this information on our website. So last piece of update here is for our active subscribers. So for active subscribers, they can request a no-cost lunch and learn for their office. This can be an introduction to ENERCALC, or discuss what's new in ENERCALC. Also, maybe showing them how ENERCALC for Revit can expedite their design process, or whatever kind of topic that we agree on, to optimize their work, your office's workflow, and reduce errors. And you can request a lunch and learn by going to our website, enercalc.com, and you can click on the for our users drop-down menu, and from there you can click on request a lunch and learn. This is very simple. You just put your name, you put your email, and you put your registration number, your KW number, and one of our staff will be in touch with you for your no-cost lunch and learn. So moving on, the focus of our session today is the design of wood columns or wood studs using ENERCALC. So to introduce this, or in summary, to give you an overview, ENERCALC can design a wood member that is subject to axial load as well as lateral loads in both directions at the same time. Also, ENERCALC can design traditional studs, engineered woods, glulam, posts, as well as multiply built-up members. You also get the ability to input separate unbraced lengths for slenderness in the X direction, separate from the Y direction, as well as input unbraced length for lateral torsional buckling for beam stability factor calculation. So if you have a column beam and you're having lateral loads, then now the column behaves like a beam, and you need to look into the flexural capacity, and now you're into beam stability factor rather than the column stability factor, and you need now an unbraced length that might be different from the unbraced length that you're using for slenderness in the X or Y directions. So let's start with an example, just to give this a little bit of numbers here. If we have a wall that's standard wall, 5.5 inch, that's the width of the wall. Span is 11 feet. Out of plane wind load, we're just using 100 PLF, and all of this is ultimate. And then dead load, we're using 2 kips. Roof live load, we're using 4 kips. And the unbraced length for buckling about the X-axis, so that's a strong direction. That's the full length of member is unbraced, so we're using the full length of member. And LU for buckling about the Y-axis, we're just going to assume that it's fully braced due to the wall being sheathed on both sides. And we assume that there is no lateral torsional buckling bracing. So for beam behavior, we're going to assume that the full length of the column is unbraced. With that being said, the process to start a wood column calculation is the same familiar process for all ENERCALC modules. You can click on the Add button, and then on the column tab, and then you click on Wood columns. So we'll start with the general tab and work our way to the left as we normally do, one tab at a time. So in the general tab, you'll fill in description of the column name or whatever, and then you'll input the column height. I always like to stress this is that the column height, or this input right here for columns, this is used for bending analysis and not for slenderness. Slenderness is controlled by a whole separate separate tab. So this is just for, calculating moments and stuff like that, not necessarily calculating unbraced length. Those are two different things. Moving on to the next part, you have your restraint conditions. This is a simple pin column. So we translate it to this. So that means, it's free to rotate and no translation around allowed. And then at the bottom, same thing, free to rotate, but no translation allowed. I typically design wood in ASD. This is what I do, and this is most of the people I know do. But if you are an LRFD fan, then you can always toggle to the LRFD design methodology, and you can move on that way. Now you need to choose the wood species and grade. So to do that, a lot of times you'll have something here auto-populated based on your default settings. If you, for example, use a specific species and you want that to be the one you start with all the time, you can set that as default. But if you want to change this, all you need to do is click on this lookup button, and this window with all of the wood species will pop up. It has all of the NDS species and design values. I am based in Oklahoma City, so Douglas fir South is the common material we use, specifically grade number 2 for all of our structural work. But again, you have glulam, you have engineered woods, you have LVLs. You can do whatever you want here. There's a decent selection. And for those of you who are working with materials that are not really included in ENERCALC or not part of the NDS, not all hope is not lost. You can go ahead and click on user defined, and once you click on this button, this allows you to create, you get this window right here, this allows you to create a new material by selecting type, grade, classification, and input all of the design value that you have, such as FB, FC, all of that, both tension, compression, everything. And what happens is that these values that you put, then when we do the design, they will be just modified by the applicable adjustment factors per the NDS, and of course per ASD or LRFD design calculations. So this covers all of the items that we need to know for the general tab, and now we're ready to move on to the column data, tab. So if you click on the column data tab, in this top portion of this tab, you can pick the member type and then select the size. So for example, just general sawn lumber, and I'm using 2 2x6s. However, you can also, if you don't have a specific size in mind, you can click on the auto select button, which helps you narrow down the various viable options. So to dig into this a little bit, if you click on it, you'll get this window right here, and you can pick width limits, you can pick depth limits, you can pick the various types of wood types, and you can also here limit it to a stress ratio. For example, some companies have a rule that for wood, they don't want to design anything more than 80% stressed or something. So you can do that here, or you can just use 1. And then you click on the start design. And what this does is that it goes through a list of, it goes through a lot of variations, and then it presents you with this list right here. Since our wall is 5.5 inch thick, then it makes sense to go with something like a variation of a 2x6. So with that being said, I figured that using here 2 2x6s is the way to go. I just picked this, but we're going to be applying loads and we're going to be doing a little bit more work that, this might be a good option or this might be a bad option. We'll see. But for now, we're using just 2 2x6s. Moving on to the lower portion of this tab, this is dedicated to the various adjustments and modification factors. A lot of these are your typical factors, like your wet use factor, your temperature factor, all of that. Flat use, for example. The factor that I want to focus on a little bit here, especially, is the KF built-up columns. I'm going to call it a factor, but the KF factor. So many young engineers have noticed either forget or sometimes are unaware of this factor, especially in places where they don't do a lot of wood projects. So a lot of them are not aware of this factor. And this factor only applies if you're using multiple laminations or multiple plies of wood. So if I'm using just a 2x6, this factor doesn't matter. But if I'm using two 2x6s or three even 2x6s, then this factor matters a little bit more. So to give you a little bit more information, the KF factor is a multiplier used to calculate the column stability factor, which is CP. So CP can be calculated either using chapter 15 or chapter 3 of the NDS. Chapter 15 has the equation as displayed right here, and you can see that's where the KF is. This equation, this portion of the equation, is the same as the CP from chapter 3. The only difference is that if you have multiple plies, then you need to add this KF factor to the normal way of calculating CP. So this factor right here depends on, of course, the member, depends on the lengths here, the unbraced lengths, the widths, but also it depends a little bit on the type of fastening. So if you're using nails or if you're using bolts to connect your to mechanically connect the pieces or the plies of wood. It is critical to know that for built-up columns, for the built-up column equations to apply, the built-up column must be fastened together based on, they have multiple other things, but this is the one that I want to dwell on, is that the connection requirement. They have to be fastened together based on 1533 or 1534, and that's where you see here nailed built-up columns. This has a pattern and requirements, and then 1534, that's if the columns are bolted rather than nailed. It has this pattern. So for a lot of for these equations to apply, you have to kind of adhere to these requirements. So now that we figured out that factor, we're good to go. We're done with the column data tab, and we're ready to move to the loads tab. So within here, the loads tab, you can click on the axial load, and you can apply whatever axial loads we have. If you remember, we have 2 kips dead and 4 kips roof live, and we elect or we choose that this load to be applied at the top. If it's applied at maybe 7 feet above the base or 3 feet above the base or whatever, you can always click on this option that says specify height, and you can tell it exactly where this load is actually applied. Next, you click on the lateral loads. This is a very similar process to wood column design, steel column design as well. But yeah, you click on lateral loads. In our case, we have 100 PLF or 0.1 kip per foot lateral wind load. That's from component cladding in our example. And the application of this load, now it wants to know if it's applied in strong direction or weak direction. So we can apply the load parallel to y-axis, or we can apply it parallel to the x-axis. So if you click on the 2D diagram, you will get this sketch right here. You can see a cross-section of the column with the axes clearly labeled on it. So for you to know which direction is which. So bending about the x-axis means that's the strong direction. So that means it's along the y. And that's the type of load we have. We have wind load that's applied along the y, which creates bending about the x-axis. If your column is loaded in the weak direction, or which is parallel to x, then all you need to do is just toggle this button and you click parallel to x, and then the load will be applied in the other direction. In our case, the load is applied in the strong direction, which is parallel to y, and we are good in that regard. Next is the slenderness tab. So we start by clicking on the buckling about the x-axis, which is the strong axis. And in our case, this is the full column height is considered to be unbraced length. Also, we have here the ability to choose our K factor based on the end fixities. In our case, it's pin, so it's this one right here, and that uses a K of 1. And for the column height, we say use overall column height. So the way to determine the unbraced length, it'll take 1, and of course multiply it by 11, which is exactly what we want it to do. Next, we click on the buckling by the y-axis, and again, this is the weak axis of the stud wall, and that is, in our example, is sheathed on both sides. Hence, we assume that the sheathing provides adequate bracing in the weak axis, and we say, okay, well, this is fully braced in the y-axis. If that's not the case that you have, then you can do the same thing where you say, click on the KY factor, just like we did here. We clicked on select KX factor, and then all of this information will show up, except that it's for the Y direction, or for the Y axis rather than the, or for buckling about the Y axis rather than buckling about the X axis. So now that we have all of this taken care of, we are ready to move to the final piece of the puzzle, which is the beam stability tab. So flexure about the x-axis, which is the strong axis, the unbraced length that controls this calculation, in our case, is the full height of the column, because about the x-axis, we say there's no bracing. Hence, it is the full 11 feet. This is critical in calculating the beam stability factor, which is CL. And this is, to give a refresher, this is for lateral torsional buckling, which is a big factor in determining the section's bending moment capacity. So that's why it's very critical here. Now, when you go to the opposite side, or the other side, which is flexure about the weak axis, we have a beam stability factor of 1. And that is because once you're loading it in the weak axis, that means the width is larger than the depth of the beam in that case. So it's a 2x6, but it's, for example, it's loaded in the weak axis. That means the width is 6 inches. The height, or the depth, is 1.5 inches if it's 1 ply, or 3 inches if it's 2 plies. Either way, it's still less than the width. Hence, lateral torsional buckling is, or CL is 1, because lateral torsional buckling really isn't a problem in this case. So now that we have input all of the information that we need to give ENERCALC to do the calculation, now we are ready to sit back and evaluate the result. That's the fun part. So if you click on the calculations tab and you click on results, you'll see here a variety of things, your bending and shear checks. But what I want to draw attention to is that on the right-hand side, you'll be able to see the controlling combination as well as the controlling formula from the NDS. This is, of course, chapter 3.9, or section 3.9 from the NDS, which is the combined axial and bending section. So that's what controls this calculation. You will have a variety of other things, such as the maximum lateral reactions, maximum vertical reactions. You'll have the lateral displacement. So you'll have a variety of good information here that can help you out. Another thing that's really cool is if you click on the detailed results, so calculations, and then you go to detailed results. If you do that, you'll get a whole new menu at the bottom or below it. This menu right here, for example, I'm clicking on the ASD axial. This gives me a lot of the information that we need for axial design. You will have the variety of the load combinations to choose from, and then you get the values incrementally along the length of the column. A lot of this information is very useful information. Like, for example, the CP, which is the column stability factor. You get, your FC. You get a variety, and you can slide this left to right. There's a bunch of critical information and intermediate steps that you can, or intermediate values that you can use for checking the software or checking hand calculations of sorts. Now, what you can also do, for example, you can click on ASD, moment about the x-axis or moment about the y, and that will also give you more of the beam design values that we would need. Like, for example, instead of CP, you'll be able to get to see the CL, which is the beam stability factor for the x direction. You can get to see For the Y direction, of course, you can get to see FB and all of that, FB compression, FB tension, you can get to see everything. This is good, good sanity check. So it's always good to see if you're looking for detailed results, you can jump into that tab. Another thing that I like to look at, which this is the one that I was referring to earlier. If you click on the 2D tab, you will have a cross section of the column, which is this is the X direction, this is the Y direction, and then you will have a look at the column from both sides, from looking along the X and looking along the Y. This shows you if you have loads applied along the X and along the Y and axial and all the stuff, you'll get to see your stud or your post from multiple angles. And of course, you can also click on the 3D tab and see that as well. Now, the last item that I want to show you here is the diagram tab. And of course, all of our calculations, or most of our calculations, have a diagram tab that shows you shear moment diagrams. And for columns, we take that a little bit step further, where you can click, for example, on the moment, and now you can see the X and the Y direction. You can do the same thing for shear. You can do the same thing for deflection and axial. And you can pick whichever specific load combination you want the plot to show for, or you can actually show all of them and just kind of see how they'll be color coded. There'll be like green and red and all that with a little legend to tell you which one is which. But this gives you a great idea of what's happening based on the various load combinations. So overall, the wood column module is a powerful module that allows the engineers to design wood columns or studs very, very efficiently and effectively. So now that we've gone through the prepared portion of the presentation, this is time for open live Q&A from the audience. So it's time for you guys to start firing away those questions. Seth, I'll pass it back to you.
All right, perfect. So yeah, like we said earlier, if you have questions that you'd like to hear answered live while we're in our session, go ahead and drop those in the Q&A tray in the lower right-hand corner. We've got a few to tackle already, so I'll go ahead and get the first one up here. Question from Pavel. Can you please clarify if you can link an existing calculation, or do you have to add a new calculation which is set as linked? Great question. So when you're talking about load linking, which is already fully integrated for steel beam module, you can get into any steel beam calculation that you have already created previously in an existing calculation module or project file, I should say. And as soon as you access that calculation for the first time and you save and close, it'll have all of the data that it needs for you to then link those reactions into another calculation. So
can I show that real quick?
Yeah, absolutely. Go ahead.
Okay. So as you can see here, you guys can see my screen, right?
Yes.
Or Seth? Okay. So yeah, as you can see here, this is all of the calculations. You can see that these, you can see this new tab right here that says calc order. And that's what I was talking about earlier, that these are non-linked loads, or they have no linked loads within them, but those ones do. So they're listed in the order that I just showed you earlier. Now, if I want to create a brand new calculation, for example, right here, and I want you to remember, I want to grab maybe from transfer girder number 1. Transfer girder number 1 is already an existing calculation. It's not something new that I created. If I click on a brand new calculation that I'm about to start, and all I need to do is jump into, let me give it a size, and let me come here to link. Let me do this here. So you can see this is all of the calculations that are outside as far as beams go. All of the calculations are outside that were already created from before. I can just grab this one, or I can grab anything. I can grab it and I can apply it at 4 feet from the left and click OK, and it just shows right here. And this is worth noting that if I have another load that I manually inputted into this, if I manually put a load by myself here in the spans, let me put it at a different place here. 9. For example, from the span loads, you can see that this is red while the linked load is blue. Red means that it's a manually inputted load. You put that by yourself. And blue means that this is a load that you linked from another calculation. This way, at a first glance, you can always see whether the load you're bringing is something that you put manually, or if it's something that's linked to something else. But to answer your question, absolutely, you can grab it from wherever you want, from whatever calculation that's already been created. So you don't have to create a calculation specifically so you can link it. It doesn't have to be that way.
Perfect. Yeah. And there's when you get into a project file, an existing project file, if you happen to get into an older project file where there is no load linking data created in that project yet, if you visit the linked loads tab, you'll just see a little note there that says, basically go look at the calculation that you want to link from and save and close it. Or you can also use the regenerate reports command to refresh all of your calculations, and then you'll be able to access load linking in an existing project file.
Correct. And just to show this in action real quick, if I have this beam right here, this is the primary girder, which has loads that trickle down. If I go ahead and if I change a load on it and I click on save and close, you can see that all of these now, they're no longer green and they changed in color because all of these are dependent on some form of an output that comes from this reaction. So you can, of course, work on these manually, or you can recalculate linked loads in bulk altogether by just clicking this button. And it goes through all of them in the proper load path order, and it updates the reactions everywhere. And Seth, I saw a question here before we switch to another one. I saw another question that says, sorry, I missed the beginning, but it says, is the linked calculation only available for ENERCALC for Revit with Revit? And that is no, this is available as a native feature within ENERCALC by itself. That is completely different from the ENERCALC for Revit interface that I'm showing right here, where it also does that and much more. But those are two different, they're doing the same thing in terms of load linking, but you don't have to have a Revit plugin or Revit model for you to be able to take care of or to take advantage of this feature. This is 100% native to your standard ENERCALC computation software.
Yeah, so when Mac was going through the what's new information at the start of our session, we actually saw two completely separate features with different capabilities, similar behaviors in different contexts. So he gave an introduction to load linking, which is completely available to all ENERCALC customers right now using just an ENERCALC project file. And then we also did a little bit of a teaser for ENERCALC for Revit, which is the Revit integrated situation where you're using your Revit model geometry to quickly generate fully functional ENERCALC calculations, and you can use the spatial connective information of your Revit model to move reaction forces from one calculation to another. So two completely distinct workflows for two different ways of working, one of which is fully native in a project file. The other is designed for Revit interop. So two different capabilities. Good questions. Next question, question from Bakar. Excuse me, does the Revit calculation consider deformation compatibility? So the short answer is no, but let's go ahead and unpack the reason for that. So ENERCALC for Revit is not a completely separate workflow from the ENERCALC calculations that you guys are accustomed to. ENERCALC for Revit is using Revit geometry to build individual discrete component calculations, just like you guys have always been used to working with. So we're creating a beam or a girder calculation, then we're creating a column calculation, we're creating a general footing calculation, and we have the ability to seamlessly move reaction forces, gravity forces in this case, from one element to another. What we're not doing is building a global stiffness matrix and analyzing it using finite element analysis for the frame of a building structure. So we're still doing individual discrete components, moving reaction forces as applied loads into successive calculations. So the answer to your question is no, we're not doing deformation compatibility because these calculations are only related to the same extent that they would be if you built them by hand individually in a project file and then copied and pasted reactions. Mac, did you want to add anything to that?
No, that's exactly what I was going to say. Yeah, it doesn't do it that way. It's a component design, and it looks at one component at a time. So
exactly. All right. Question from Pavel. If you bend about the x-axis, shouldn't you be fully braced by the sheathing as the lateral torsional will be in the weak axis? So he's talking about your stud situation where you're braced by wall sheathing, bending about the strong axis of the column. And he's saying, then wouldn't you be braced for lateral torsional effects?
Is the Let me get back here. I think the more part that I'm focused on at this moment is the ability that you can do whatever you want to do. Whether if your interpretation is that you're fully braced, you can go ahead to the beam stability factor and say, I'm fully braced. Or if you want to say, no, it's not fully braced, it's 5 feet or 6 feet or whatever, you can put that here. So at least that's the purpose of the example, is to let you know that you can do whatever you need to do. So now let me actually go back to the example, because I have that as an input. So I'm saying no lateral torsional buckling. Yeah, if you want to consider the sheathing to brace it for lateral torsional buckling, then you can just say, nope, that's zero. It's just for the assumptions for this example is saying that use the full length of member. So based on this example, based on the assumptions and the given, I guess what I want to make sure is that I was trying to replicate what the example is telling me to do, not necessarily think about or make an engineering decision. That would be for you to make an engineering decision that works for you. And the main thing is that ENERCALC will allow you to do that as you see fit. If you want to say this is fully braced, great. If you want to say nope, this is not braced at all, you have the options to do whatever works for you. And Seth,
Right. And
there's another. Was there a follow-up?
Yeah, he had a follow-up. He said confusion about the about definition. If the load direction is XX parallel to XX, then you're for sure braced in YY.
So let me show him here what we're talking about that.
Yeah.
Okay. So we're gonna go to loads. So you see this right here. When you have a load that is about the x-axis, then this load is loading the member in the strong direction. So and this is consistent with the NDS and the AISC definition of loads, is that when you have a moment about the x-axis, that means the direction of that load. So if I'm applying a point load along the y, parallel to the y as shown by this arrow, then that will create a moment about the x-axis. So does that kind of answer his question? Because I couldn't see his follow-up.
Yeah, so the directionality is shown in the 2D sketch here, and then when you go to the beam stability tab, then you should notice
structure about the x.
Yeah, and that's
so that's the proper way. But again, as I told you, not necessarily to get too boggled down on whether we're supposed to use 11 or 0 or 1 or 5. I think the point that I was trying to drive home is that you can do whatever you want based on your unique conditions.
Right. Yeah. All right. Question from Ilya. Does this module check for biaxial loading? And that is pretty much yes across the board. For all column modules, you have the ability to apply axial compression and flexure about 2 axes.
100%. And that's why here, because this column is loaded in both directions, axial and bending in the strong axis, you can see here that the governing formula that controls this design is the compression plus mx, which is the moment above the x-axis. So chapter 3, section 3.9 of the NDS, which is combined axial and bending.
Perfect. Okay, question from Jessica. How soon are we going to be able to link loads for wood beam and column design? So Mac, you want to go back to the good old survey page. So there are several aspects of this process that are in active development with the dev team right now, but you also have the opportunity to go and make your voice heard about what you want to see integrated. So that's what Mac's going to show you right now.
So the way that we do these, we can't do all of them at once. Unfortunately, we have a lot of modules that can link together. So the way it works is that based on the votes, If we get 100 people saying we want wood beams and we have 2 people saying we want steel columns, then we're going to develop the wood beams because that's what what the users want. For you to make your voice heard is very simple. From ENERCALC right here, you can see we have plans to support all beams and all columns. That's the plan is there. But in order for us to figure out which one to develop next, or the order of development, just click on columns, click on load linking survey, and that will take you to this page. You can click start. You can pick the one that you want. You want the load to go from a steel beam, and you want it to go to, I don't know, a steel column. You can do this, and then you can click submit. So it tells us what people want. You can go here. You can break that button. You can go ahead and vote 1,000,000 times. Let us know what you want, and we will drive that development in the direction that our users want.
All right. Question from M. Is ENERCALC for Revit a separate license we need to purchase separately? Yes. ENERCALC for Revit is an add-on to your standard subscription. There's a lot of information about ENERCALC for Revit on our website. There's a separate dedicated page for EFR and Revit integration stuff. If you have questions about quotes or purchases or adding ENERCALC for Revit to your subscription, you can just reach out to info@enercalc.com. That'll get you to the business office where they can answer all your questions about adding ENERCALC for Revit to your regular ENERCALC subscription. And ENERCALC for Revit currently supports the same Revit versions that Autodesk supports. And so that's currently Revit 2022, 23, 24, and 25. So when Revit 2026 releases, probably April of next year, then we will also release support for via ENERCALC for Revit 26, and then 22 will drop off and will support the latest 4 versions again.
That Seth, I want to get back to Pavel here's got, I saw his last point, and this is really good discussion. I love this. If you go to the wood column or the steel column for that matter, but if you go to the wood column under loads, you see this right here that says load reference guide. This is the sign convention and everything that we are using. So if there is ever a confusion, I know our language is consistent. Like, when you look at something and buckling about the x-axis, flexure about the x-axis. So the language is consistent, but the premises of all of this is in the load reference guide. So if there's ever some sort of confusion, this would be what we use in ENERCALC, and it is consistent, of course, with the AIC and NDS. But just in case if there's ever a confusion, that would be like a quick sanity check that can be done. And of course, we're support at enercalc.com is always open for questions, big or small.
Yeah, for sure. That was what I was going to add is, be sure to reach out to the support team if you want to dig into that further. Also, I'll point out, if you go to the beam stability tab, you have flexure about XX and you also have flexure about YY. And those 2 tabs will tell you by inspection that the flatwise direction is not subject to instability effects. And so basically, and you have to keep in mind when you set your slenderness behavior, for example, if you say, hey, we have some sheathing here and this sets our slenderness restraint so that we're not going to experience axial buckling, that doesn't automatically bleed over to your beam stability tab. The engineer has the ability to specify those individually. Question from Susan: how can I update ENERCALC under the latest code? So that was a little bit of what Mac covered at the beginning. You can use your update button at the top of the window right there, or you can always go to your general program settings and use that checkbox right there at the bottom of the screen.
I can show it quickly. You click on the update button, then you click on this page or on this button right here. This will automatically in your browser brings you to this page. You can download ENERCALC from scratch. You can update whatever you have right here. That's the one that we use. And if you scroll down and if you use ENERCALC for Revit, you can always update from right here. So all of the updates are housed in this page.
Perfect. And whenever you do that latest update, that's automatically going to pull whatever are the latest building codes we support, which includes IBC 2015, 2018, IBC 2021, and then we have loads and forces modules coming out progressively for ASCE 722. And some of those are out now. Some of them are in active development right now for the 722 loads and forces modules. Excuse me. Follow-up question from M. What are the modules that currently have linked calculation features? Is there a live list that shows them as you're adding them? So steel beam to steel beam is fully integrated for load linking at this time. Wood beam load linking is in active development with the development team right now. And when wood beam is done, that'll open up wood beam to wood beam, as well as crossover linking between wood beam and steel beam back and forth, either to or from. And then the subsequent load paths or development pathways are going to depend on what we hear from customers. But obviously, we're going to get columns involved. We're going to get those other fundamental gravity load paths. But no, we don't have a public roadmap, so to speak. That's why we encourage you guys to come hit these events so you can hear what's happening. And then whatever those new modules are integrated, they just roll automatically with the latest updates. So let's say, for example, whenever the next module is done, when it's ready to go, you're just going to see it pop automatically whenever you pull that latest update in the month that it becomes available. All right. Well, that pretty much brings us to the end of our time for today. Thank you, everybody, for a lot of great questions. Mac, I will toss it back to you for any final thoughts and for any information you want to give about next month's session and subsequent office hours topics. So I will go ahead and toss it back to you, and you can wrap us up.
Yeah, absolutely. This brings it into today's session, and then our next session is going to be in October. I believe it's going to be October 9th. Let me check that. But yeah, and we are planning on covering wood shear walls. That would be the topic for next session. So, but that's about it for me, and I think we're good to go.
All right. Thank you guys again, everybody, for being here. Again, we encourage you to swing by our office hours page on the website to make sure that you sign up and get notified. That'll keep you posted when these sessions are coming up. And until then, we'll look forward to seeing you guys next month. Thank you all very much.